Okay, welcome. We are at the second section for this topic, the operation in discrete signal convolution, which we are focused on convolution and also and transfer function only. Alright, so I would like to discuss about the convolution. Convolution. I still remember during your test you have one convolution question for the discrete, is it? And then you need to solve it. However, in order to solve it, you need to do a very huge amount of the work, is it, in order to get the answer. However, if we try to solve the discrete in a Z transform, it will be easy. For sure, it will be easy. Also, I will compare. So let's say you have Hn, Yn, Xn. And then the question asks you to get what is the Yn output. So in order to get the Yn output in discrete signal, you need to multiply the Xn, the input discrete signal, convolution with the Hn. And then you can see there is so much work in order to get the Yn. However, if we convert everything in Z transform, this block diagram will convert like this. This is Z, and then Y, Z, Y, Z. And then, in order to get the YZ, you just multiply with the XZ and HZ. Simple multiplication. So, you can see the benefits of the Z transform. If you try to solve it in discrete, it's very long to solve it. However, if you convert to the Z transform, you just multiply the signal and also the system. Then you get the output of the signal and system. That's all. Okay? It's also similar with the Laplace. If you try to solve it in time domain, it's very difficult. And then that's why you convert to the Laplace transform, similar. And then you get Ys equal to Xs multiply Hs, you get the answer. So the benefits of the Z transform and Laplace are comparable. However, the only difference is the Z transform process the discrete signal. However, the Laplace process the time domain signal. Okay. Similar with the Laplace also. So this is convolution. In order to solve the convolution, we just convert to the Z transform and then you just multiply them together and then get the answer. Okay. However, if you still remember, what is the definition of the transfer function? The definition of transfer function is output divided by input. Okay, output divided by input. So similar with this one, you know that this is output. This is the input. Then you get the transfer function. So in this case, it will be Yz divided by Xz. You get the Hz. So this is the transfer function. So what is the benefit of the transfer function? The benefit of the transfer function, you can check the system stability. So this thing I will discuss in the section number 3. So we continue for the first example. The first example we focus on the convolution, okay? The convolution. So the question is, solve the convolution for the signal below. I believe if we try to solve this one using the discrete, so you need more than 1 day to solve this question, I believe. Okay, because it is a sine wave, the sine wave in discrete form, is it? So in order to make your life easier to solve it, we need to do the Z transform. Okay, if you still remember in the section 1, I give you this thing, sine 2 pi n un. When you want to convert to the time to the Z transform, I show you the simplest pi 1 n un. If convert to the Z transform, you get Z sine pi 1 over Z power of 2 minus 2 cos pi 1 Z plus with 1. Okay. So in this case, since we have two signals here, the first signal and second signal, is it? So we just need to take the first signal is sine 2 pi n un. So we need to convert to the Z. So by following this one, so you get Z sine. So the pi 1 here, sorry, the omega, the omega 1 here actually equal to 2 pi, is it? The omega 1 here is actually equal to 2 pi if we compare with this form. So every omega in this information we need to replace with a 2 pi. So you get Z sine 2 pi over Z power of 2 minus 2 cos 2 pi Z plus with 1. If you use your calculator, sine 2 pi, what do you get? So if you use the calculator, let me use my calculator. To solve this, you can use your calculator to get the value. Since this in 2 pi, so it means that you need to set your calculator in radian, okay? So what is the value of sine 2 pi? Sine 2 pi equal to 0. Okay? And then Z power of 2, and then cos 2 pi, cos 2 pi equal to 1. Z minus 2, Z power of 2 minus 2 multiplied with 1, Z plus 1, and you get 0, Z power of 2 minus 2Z plus 1. Since 0 divided by everything here, it becomes 0. Okay? And then the second part is, you have the second signal is 2un. 2un. The next signal we have 2un. Okay? So since according to the Z transform table, the un only equal to 1 over 1 minus Z inverse. Okay, or we can write as a Z over Z minus 1. Same thing, they are the same thing. Okay, so since we want to convert to the Z transform, become 2, the un becomes Z over Z minus 1. So finally you get 2Z divided by Z minus 1. Okay, so this is the formation. The sine 2 pi n un, finally you get 0. 2un, you get 2Z divided by Z minus 1. So finally, the answer for the xn the final for the Sn, we convert to Z transform become xz equal to 0 multiply with the 2z divided by z minus 1. Finally, you get 0. Okay, so you can see that it's very simple if you convert to the Z transform. Okay, this is Z transform sin 2 pi n un, and then you convert to Z transform, you get 0. And then 2 un, if you convert to Z transform, you get 2z divided by z minus 1. And then you just multiply them together, and then finally the answer is 0. So next we go to for the example number 2. Okay, so we go for the second example. The question is find the transfer function when xn equal to in bracket negative 1 over 3 power fn un, and then the yn equal to 1 over 3 power of n un minus 1. So the definition of the transfer function is output divided by input. This is the definition of the transfer function. So this is in yn. However, the transfer function must be in yz. This is xn. The definition of the transfer function, it must be in xz. So it means that what you need to do, you need to convert to the xz and also the y of z. So this one is similar with this. This is alpha. This is alpha. Power of n multiplied with the un. However, for the second, is similar with this one. This is alpha power of n, u, n minus 1. So if we convert it, it becomes z over z minus alpha. So you get z over z minus, what is the alpha value? The alpha value is equal to negative 1 over 3. Negative 1 over 3. Finally, you get z over z plus 1 over 3 for this one. For the yz, we need to refer to this one. You get 1 over z minus alpha. The alpha value is 1 over 3. 1 over 3. So this is the value for the xz and yz. Okay, so the transfer function, the definition is yz divided by xz. So what is our yz? The yz is 1 over z minus 1 over 3 divided by the xz. The xz is z over z plus with 1 over 3. Is it? So finally, we solve it. It becomes 1 over z minus 1 over 3 multiplied with the z plus 1 over 3 divided by z, and finally you get z plus 1 over 3 divided by z multiplied with z minus 1 over 3. So this is the answer for the transfer function. Okay, it's very easy. It's very straightforward. So what you need to do, you must have this table, must know how to use the Z transform table in order to solve it. And then previously, for the example number 1, we discussed about the convolution. In order to solve the convolution in Z transform, you need to use the information from the Z transform table. And also, in order to find the transfer function also, for example in number 2, you need to also use the information from the Z transform table. Same thing. Alright, so this is very straightforward lah. So the example number 3, we will discuss how to do the inverse Z transform.